So let me say this two ways. So you can extract energy from the nucleus of an atom in two ways.
Right.
Take a big atom, split it, and the mass of the two products is less than what you started with. Where did the mass go? It became energy. E equals mc squared.
Nice.
The E and the M, they're on opposite sides of an equation.
Right.
If you get rid of the M, you get E on the other side. Okay.
And that is fission?
Fission.
That's fission.
Fission.
That's
big atom into little atom.
Little atom.
Now you come from the other side.
Okay.
You take little atoms and you bring them together, make bigger atoms.
Okay.
Okay. Then the atom you ended up with has less mass than the two atoms you started with.
Same in reverse.
Okay, so now we got some mass that becomes energy.
That's very cool.
That's fusion.
That's cool.
Fusion. Okay, so we know how to begin and sustain and contain fission.
Right.
Okay, a lot of research went into that to make the bomb.
Right.
Okay, that would be uncontrolled fission.
Uncontrolled
okay,
fission.
if you're not controlling it, it explodes.
Right.
And that's where you get the bomb, the Oppenheimer and the A-bomb and all of this. And there are two kinds of A-bombs. One used plutonium, the other used uranium.
Wow.
Those are huge atoms. All right, you come from the other side, you start with hydrogen, the lightest atom. You fuse it, you make helium. That's what the sun is doing every moment of every second of every day, 24/7. Okay, so that takes very high temperatures, and the temperatures are so high, like, what are you gonna put it in?
Right.
Okay.
I'm gonna go with
it's millions of
Pyrex.
It's millions of degrees.
Millions of degrees.
Everything you put it in will vaporize
before you even has a chance to do it.
This is one of the challenges of this exercise. And so maybe you can contain it in a magnetic bottle.
Ooh.
Yeah.
Yo, that's super cool
That's
because
dope.
now you're using the magnetic force
to contain it.
That's
No, it's brilliant.
brilliant.
Brilliant. It's brilliant.
I'm on board. Let's do this.
Why didn't we think of that before?
What are we waiting for? What are we waiting for?
So there are different styles of this exercise. The tokamak, it's a machine that creates a toroidal volume where you would then have your plasma, very high temperature gas, ionized gas, and in there you'd get the fusion. So the problem is...
Wow, that's so cool.
No. By the way, we've made fusion bombs.
Right.
So we have uncontrolled nuclear fusion.
Right.
They're called bombs.
Yes.
The sun is in full control of its nuclear fusion because at the center of the star and the pressure surrounding it from all the rest of the star keeps it in check.
Right.
Okay? Otherwise, the whole star would go kablooey.
Yeah.
Official term.
Kablooey.
Kablooey.
I love it.
There's no uncertainty about the meaning of that word.
You can't mess that up. Kablooey.
So some of the challenges are, how do we control it once you get it started?
Okay.
And we've not been able to do that effectively, really. But recently, months ago, in the United States, and I think it was at Lawrence Livermore Labs, they managed to get more energy out
than they put in
to make this whole thing happen.
Well, that sounds to me like the nascent stages of fusion reactors.
Yes, it is. But all the information about this wasn't fully reported on.
Uh-oh.
No. I mean, it's just the experiment, the energy that goes in the experiment versus came out, it was net positive.
Okay.
However, what it took to set up the experiment in the first place,
right.
The whole kit and the caboodle to get to that volume in which you had the fusion is itself a whole expenditure of energy and technology.
Exactly.
And so it's a first step to show you that it's possible. And what you have to do is make everything else efficient that's around it on the hope and expectation that one day this can run
like the electric car. Like the electric car, once you have it and you're driving it, it's doing great in terms of if you take renewable fuel and use that to put the electricity in the car, what you're doing is you're net zero.
Net zero.
But the fact is, if you made more pollution making the car
that makes no pollution.
Yes.
So it was an important test of concept. It made headlines, by the way.
Right.
And I was interviewed heavily about it, if I remember, on CNN and this sort of thing. So I was very happy about that because there's no shortage of hydrogen in the universe. It's the #1 atom.
Yeah, right.
All right?
Yeah.
Did I tell you I was listening to a radio play one time? There were aliens that were coming to Earth to suck up our water supply.
Right.
Because they thrive on hydrogen.
Right.
And they knew that water is
It's
H2O,
right.
H2O.
Right.
All right. And I'm listening to this. They came across the galaxy to consume our water supply,
Right.
to get
The
hydrogen. When
Only the most plentiful thing in the entire
98% of all atoms in the universe are hydrogen.
hydrogen.
These are some stupid aliens.
Right.
And so I was very disappointed in that story.
And you get the good hydrogen on Earth. Come to Earth, the best hydrogen there is. Yeah, no.
So anyhow, so there's no shortage of hydrogen.
Right.
And so if we could perfect this process, then it's unlimited energy for practically zero cost for the rest of the world and all of civilization.
Wow.
And it's not dependent on if the sun is shining or if the wind is blowing or if the tide is moving or what oil well you dug.
Right.
Or it's not dependent on any of that.
Any of that.
Yeah.
Wow, it sounds like a wonderful dream. Well, listen, it sounds like we're on our way.
That's right. But people still have a spook factor about nuclear power.
Yeah. Well,
There's still a little, if you told them how many people died mining coal
oh my God.
to supply their energy that we've been using for the past century and a half.
Right.
Yeah, it's hundreds of thousands of people.
Oh, without a doubt.
Right.
Not to mention how messed up their skin is just because of it. It's terrible.
Or their lungs.
Or their
Yeah.
lungs. God.
I had a geeky childhood. Right?
Okay.
So I always wanted to know what was the longest word in the biggest dictionary.
Okay.
And at the time, my access to dictionaries included the Random House unabridged dictionary.
It's the best.
Okay. I didn't know about the OED, but the Oxford English Dictionary, but the Random House was nice and big.
Yes.
Found the biggest word.
Yeah.
Okay. Mm-hmm. It's pneumono-ultramicroscopic silicovolcanoconiosis.
God bless you.
Sorry.
So sorry. I'm so sorry that happened to
That
you.
is sensibly abbreviated to black lung.
Wow, is that what that is?
That's what that is.
Black lung.
So pneumono,
Right.
ultramicroscopic,
Okay.
silicover. So that's like the
Tiny
silicates.
little silicates
Right.
inside the pneumono lungs.
Yeah,
right.
right. Canoconiosis. So it's the medical folks staple together
Yeah, they
all
just-
the
yeah.
all the syllables. But
Right.
so that's coal and it's coal dust and people died from this.
Oh, yeah.
So I'm not here to say fewer will die with this. That's not the right way to approach this. Just demonstrate the safety
Right.
of these nuclear plants and maybe people will come around.
Pneumono stuff. Better known as